Alright, tonight I'm going to be showing you how to capture gases using the water displacement method. Now, for those of you who are unfamiliar with the water displacement method, it's a reasonably simple concept. You have a test tube or a small container over here where you start a chemical reaction that generates gas. Running from the test tube or your container, you have a hose leading to a bottle filled completely with water. You can't have any air in it or it'll interfere with your gas purity. In mine, to make sure no gas escapes, I have a cap on it and I have a second hole right here so that the water can drain out as the gas moves up. During the reaction, this bottle will be inverted so the water will drain into this pail. When the reaction is complete, you should have a bubble of gas in the top of your bottle. And tonight I'm going to be showing you how to generate two different ones, hydrogen and oxygen. We're going to start up with oxygen, so I'm going to go prep the containers. Okay, we're going to start off with oxygen. This is the easiest one to generate since the materials to do it are the most readily available. How we're going to do it is in this test tube here, you can see I have a clear liquid which is hydrogen peroxide. Just the 3% that you can get at a drugstore will do. And as a catalyst to break it into water and oxygen gas, we have quick rise yeast. That you can get at a grocery store. It's probably around the bread section. This is, however, the slower of the reactions. So we're going to pour our yeast in and close the cap. And shake it. Now, as you can see, and probably hear, there's oxygen bubbling up in the center of the bottle. And as you can see, the water is dripping out through the second hole to provide room for the gas inside the bottle. So we're just going to leave this go for a few minutes and we'll come back when the reaction is complete. Okay, you can see we got our oxygen gas in the top of the bottle already. Now we're going to generate hydrogen gas. For this reaction we're going to be using muriatic acid, which is very, very strong hydrochloric acid, and pieces of zinc metal. I have about 10 or 15 milliliters of HCl in the test tube already, and to start the reaction we simply drop the zinc in. This one is critical to keep upright because some materials will get eaten by hydrochloric acid and I don't want anybody getting burned. So we're going to start it and generate hydrogen. As you can see, this one's much, much faster than the last one. The hydrogen reaction also goes a lot longer than the oxygen reaction. Now, since hydrogen doesn't burn, it explodes. Be very careful about how much hydrogen you mix in with that oxygen, because if you get it just right, I could rupture the bottle with just the amount of gas I have in it right now. And now that the reaction seems to be slowing down, I think I'm going to disconnect it before I get any more gas in the bottle. When I come back, we will see if we can set this off and create water. Alright, now we're going to attempt to actually set this off. I have inside the bottle is a barbecue lighter, and hydrogen and oxygen can sit in the atmosphere together and not explode because you need heat to start the reaction. So let's see if we can get this to light off.